Hello everyone, hope you're all doing good and welcome to this video. I hope you're all making some good progress in your Kubernetes adventure. Right, in this video I'm going to talk about the stateful set. Um, what I'm going to do now is I'm going to talk about the stateful set, but meanwhile I'm going to bring up my cluster because it's going to take 8 to 9 minutes for the cluster to be provisioned. So instead of wasting time, let me bring up the cluster. So if I cd to play directory and I git clone my Kubernetes repository, I'll put the link in the description for this GitHub repository. Cd to Kubernetes and then to Vagrant provisioning and do Vagrant up. So what this is going to do is this is going to create a 3-node Kubernetes cluster with 1 master node and 2 worker nodes. It's going to take a while, so while it's deploying the cluster, and I'm going to show you my nodes here, what I'm going to be doing in this video. Okay, so Statefulset. Regarding my setup, I've got an Linux virtual machine, Linux host machine running Manjaro Linux. And as you saw, I've started provisioning the Kubernetes cluster with 1 master node and 2 worker nodes. They're all running on virtual boxes provisioned by Vagrant provisioning. They're all CentOS 7 machines with the master node having 2 gig of RAM and 2 CPU, and each of the worker nodes have 1 gig and 1 CPU. Statefulset. So mostly the applications are stateless when it comes to containerizing and running in the cluster, but we also want to have some stateful applications. For example, MySQL applications that are stateful. And in case of web applications, if you want it to be stateful, you need to store the data in a persistent volume, persistent storage system. And in this video, I'm going to set up an NFS server similar to the one that I did on my previous video about NFS provisioning, persistent volume provisioning. And here, I'm going to export this directory srv nfs kube data. So this NFS server will be running on my host machine, and I'll be exporting this directory to the cluster. And I'll be creating subdirectories, persistent volume 0 through to 4, just for this demo purpose. Okay, so Statefulset. What I wanted to tell you about Statefulset is there are a few things that makes Statefulset different to the deployment. There are 3 things. One is it has got a unique name, and then it has got a unique network identity, and a unique stable storage. I'll tell you what each means. And then there's an ordered provisioning. So that's the characteristic of a Statefulset. So I've got 2 worker nodes in my setup, kworker1 and kworker2. So if you're rolling out a Statefulset with 4 replicas, for example, the first one will get the name of the name will be the naming convention will be the name of the Statefulset. If I name the Statefulset as web, the pods in the Statefulset will get the name with the name of the Statefulset along with the numerical value starting from 0. So if my Statefulset is named web and with 4 replicas, then each of the pod will have the name like web0, web1, web2, web3. Right, ordered provisioning. That means when you create the Statefulset, all the pods won't get provisioned in parallel, although you can do it, but by default, the first pod will get provisioned, and once it's provisioned, and only when it's ready, it will go and provision the next pod, web1, and then it goes to web2, and then when web2 gets ready, it goes to web3. So that's ordered provisioning. And when you delete the pod, when you delete the Statefulset, again the ordering is important. So it terminates the last pod that it created. It's a last in, first out kind of thing. So it deletes the web3 first, goes to web 2 and then to web 1 and then to web 0. So for example, when it tries to delete web 3 and it can't delete web 3, it won't delete web 2. So unless this pod, the web 3 pod, is completely destroyed and terminated, only then, one and only then, it will go to web 2 and then to web 1 and finally to web 0. This is the same case when during the provisioning. So web 0, only if it's ready, and it will go to web 1. And once web 1 is ready, before going to web 2, if web 0 fails, it won't provision web 2 unless web 0 becomes available again and ready. So that's the kind of the characteristic of a stateful set. So ordered provisioning and ordered termination, and also when it comes to scaling or rolling out the updates. So I did a video on how to perform a rolling update of applications in your Kubernetes cluster. So when you perform a rolling update, the updates will happen from the last. So the web3 part will get updated. For example, if you deploy an Nginx or a MySQL stateful set, this part will get updated first, followed by this part, and then this part, and finally this part, right? Okay, so when it comes to stateful set, we always need to store the volume on a persistent disk. So that's stateful, right? If we don't care about the underlying data, then it's stateless. So we can create as many pods as possible. We can destroy them. We can recreate them. That's not a problem. But when it comes to data, preserving the data, persisting the data, that's where the stateful set comes into picture. Right. So what we do is we create persistent volumes. Again, um, this has to be done by your cluster administrator. He has to create the persistent volume beforehand, before we create the stateful set. That's static provisioning. We also have dynamic provisioning. So if you happen to use a Google persistent disk, one of the cloud providers, then there is dynamic provisioning. You can create storage class. You can create templates. You don't have to pre-provision the persistent volumes. So when you are coming to deploying the stateful set, you can create a persistent volume claim where you can specify a storage class that matches the storage class defined in your cloud. So, but unfortunately, as I'm not using cloud, I'm using the local cluster here. The dynamic provisioning is not supported for NFS plugin. So I had to pre-provision the persistent volumes. And how would you use this persistent volumes? You can either create a persistent volume claim manually, like what I showed you in my previous video about NFS persistent volume provisioning, or you can include a volume claim template, which I'll show you in a minute in my YAML example. You can include a volume claim template within your pod specification. So when it binds to a persistent volume, it remembers that association. So this pod is associated with this persistent volume, and this pod is associated with this one, and so on. So what this means is, even if you delete this pod web2, for example, um, and if you delete it or if it gets rescheduled, say for example, now it's running on kworker1 and the PV2 is mounted on kworker1, obviously. When you delete it, kubectl delete this pod, Statefulset has to maintain a replica of 4. So it's going to create another pod of web2. It might create it on kworker2, for example. And even in that case, it will still mount the same persistent volume it used before. So that's the characteristic of Statefulset. So it won't go ahead and mount a different volume, although more volumes are available. It will stick to the same volume it used previously and the same name. If web2 is deleted and the Statefulset deploys a new pod, the new pod will get the same network address. That's the unique DNS entry across the cluster, and the same pod name, same persistent volume and everything. So if I show you a demo, you will better understand it. Okay, let's see where we are with the provisioning. Okay, so I think it's going to take another couple of minutes, and I'm going to pause the video here and come back when it's ready. All right. The cluster is set up. Cluster has been provisioned now. So as usual, I'm going to copy the Kubernetes config file from the kmaster to my host machine so that I can run the kubectl command from my host machine to interact with the cluster. Make directory.kube and scp the config file to my local machine. That's the wrong password. Okay, so that's copied. And if I do kubectl cluster info, kubectl get nodes, 3 nodes ready, kubectl version minus minus short. Okay, so we're all in good shape now. Okay, and what I didn't do is I wanted to create the persistent volume first. Let me create the persistent volumes. Before creating the persistent volume, I need to set up the NFS server. Sudo, if you're on Arch Linux, you can install the NFS server using the package NFS utils. I've already installed that, so I'm not going to install it. So once you install it, you enable the service and start it. Systemctl enable NFS server, systemctl start NFS server, and you're going to edit the etc exports directory. I'm going to add srv nfs kube data, and I'm exporting it to the world. Read write sync no subtree check and insecure. So if you want more details about this, in my previous video I talked everything about this NFS persistent volume, so I would suggest you to go ahead and watch that one. So I'm going to quickly do that. Sudo make directory kube data, and I'm also gonna make their srv nfs kube data pv0, pv1, pv2, pv3, and pv4. I'm going to change mode -r 777 to all the directories under srv nfs. Okay, so let's export it. Export fs -rav. If I do sudo export fs -v, I can see whether it's exported. And also show mount -e, so that's all looking good. I'm going to quickly log into one of my worker node to see if I can mount this volume actually. Mount -t nfs, and my IP address of the host machine is 192.168.1.10 srv nfs kube data /mnt. Cool, I can mount it. And you mount grep kube data, so that's mounted. ls mnt, I should be seeing srv nfs kube data. Oh, why is it? Did I make it sudo make that? Okay, let me start that again. You mount mnt srv nfs. That's the mistake I made. It should be a slash. Change mode -r. Okay. Right. If I do that command again, mount -t nfs 192.168.1.10 srv nfs kube data to /mount ls/mnt. Okay, cool. That's looking better. I'm gonna unmount that one. Exit out of it. Okay. Let's go one directory above and into the YAMLs directory. So I've got these two YAML files for this demo. One is to create the persistent volume. The other one is to provision the stateful set. Right. As I'm using a local cluster here, I have to do a static provisioning of storage, which means you have to pre-provision the persistent volume before creating your stateful set. If you're using a hosted cloud provider like Google, Amazon, or Microsoft Azure, you could use dynamic provisioning where you create a storage class, you create a template, and then when you deploy a stateful set, it's going to create a persistent volume climb, and the persistent volume will get provisioned automatically. And when you delete the persistent volume climb, it will delete the persistent volume. But in case of static provisioning in my local cluster here, I have to provision the persistent volumes beforehand. And in my case, if I delete the persistent volume climbs, my persistent volumes won't get deleted. It will get deleted only if it's a dynamic provisioning. Okay, let's take a look at what's inside that YAML file. Okay, so basically I'm creating 5 persistent volumes. They're all identical except the name, pvnfs pv0, storage class is manual, and the capacity is 200 meg. Access mode is read write once, and the path is srv nfs cube data pv0. And I need to edit the NFS server IP 192.168.1.10, and this is for PV1. Again, same set of code except the name 192.168.1.10. This is for PV2 192.168.1.10. This is for PV3 192.168.1.10. This is for PV4 192.168.1.10. Okay, so let's go ahead and create these persistent volumes. kubectl create -f. So all the persistent volumes got created. If I take a look at the persistent volumes, so those are the names pvnfs pv0 through to pv4, each of them with capacity 200 meg, with read write once access mode. Reclaim policy is retained, which is the default. All of them are available, not bound to any persistent volume claim at the moment. Storage class is manual. Okay, I explained about the reclaim policy in my persistent volume videos, which basically means if you're using a pod making use of a persistent volume claim to use one of these persistent volumes, and when you delete the pod and the persistent volume claim, it won't delete the persistent volume. It will change the status to released but not available, which means even though you delete the pod and the PVC, this PV will still remain there, and it won't be available for other PVC, for any other persistent volume claims. Any other claims can't basically use this persistent volume. So that's the default reclaim policy. But if you want, so once you delete the persistent volume claim, if you want this persistent volume to be available for other claims, then you need to change the reclaim policy to release. I think, yeah, to release. That will basically delete all the data, basically like rm minus rf, the entire content in that persistent volume, and make the persistent volume available for other claims. Okay, so we've created the persistent volume. We don't need to create a persistent volume claim because I'm going to show you the Statefulset deployment. Okay, so in Statefulset, one thing you got to notice is we are going to create a service called headless service, which is identified by the cluster IP set to none, basically. But if you want to access this application, if you want to expose this application, you still need to create a separate service for it. But this headless service is mandatory, which is the way to link all the pods in this stateful set. So the characteristics of Statefulset is it has a unique network identity. Each pod will get a unique network identity. Each pod will get a stable storage. Each pod will have a unique name, and the ordering of the pod is important. It's all ordered. First pod, it gets created and then goes to the second pod, to the third and the fourth, and so on. And termination is like last in, first out. The last part will be the first one to be terminated, and so on. Okay, I think that I explained those in the start of the video. And the thing to remember here is it needs a headless service for to maintain the unique network identity for each pod. Okay, coming to Statefulset, I've created the Statefulset with the name nginx-sts and the service name here, which headless service we are going to use for the Statefulset. nginx-headless. This has to be the same as the service we created above. Okay, so this Statefulset will have two replicas. I'll come to pod management policy a little later, um, which is basically the default is ordered. The default pod management policy is ordered. As I explained, it goes in sequential order, either when it's during the creation or it's during the deletion of the stateful set. But if you want all your pods to get deployed at the same time simultaneously, then you can change the pod management policy to parallel. I will show you this demo after my the initial demo. Okay, and these are all basic stuff. I'm deploying an Nginx container, and the volume mount is dub, and which is going to get used from this volume claim template. We are using the volume claim template with the pod specification, with the stateful set specification. We're not using a persistent volume claim. So this volume claim template specification can only be used within a stateful set. If you try to use that in a deployment set, it won't work. You will get an error. So here basically we are, and this name we are giving to the volume claim template should match the volume mount name you have given. And the storage class name is manual. So we've got the manual storage class for all the persistent volumes we created. The access mode is read write once. So again, read write once is what we have on all our persistent volumes. And the amount of storage we are requesting for each pod is 100 meg. So each of our persistent volume is 200 meg. So it satisfies all of the conditions. So we should all be good now. Okay, let's try and create this. But before that, I'm going to change the deployment from the replicas to 2 to 4. Okay, so now let's deploy the stateful set. kubectl create -f, that one. Okay, and on the top pane, what I'm going to do is, as you can see, there are no persistent volume claims, but when you deploy the stateful set, it will create the persistent volume claims for us. So I'm going to watch the kubectl get all command to see how the pods are getting created. Okay, I'm going to hit enter now. Right, the headless service is created, and you can see the first pod is getting created, and then the second and third, and finally the fourth pod. So that's the ordered creation. So when you're creating it, it's going to create the pod one by one, not all of them simultaneously. Okay, and that's the headless service, and the name of the pod will be the name of the stateful set, which is nginx-sts, followed by the number in sequential order 0, 1, 2, and 3. Okay, so now if I show you the persistent volume claims, kubectl get pv and pvc, well, you can see here it's all got bound to the persistent volume. So these are the persistent volume claims that got created as part of the stateful set deployment. And so that's the pod 1. It got bound to the first volume here, and the second one got bound to the second volume here. So what this basically means is if you delete the pod, even if you delete the pod and recreate it, it will still get the same persistent volume. Okay, to show that in example, what I'm going to do now is I'm going to get a shell into a container, one of these. For example, if I take nginx-sts2, for example, kubectl exec minus it nginx sts2 bin shell. Okay, so in our pod specification, we have mounted the volume under var dub dub dub. So let me go to cd var dub dub dub. There's nothing at this moment, and I'm going to sts2 is the one that's using pv nfs pv2 as the persistent volume. Okay, let me touch a file. Touch hello, for example. Okay. So basically, so that's the volume here. Now what I'm going to do is I'm going to delete that um, pod and let it recreate and let the stateful set recreate the pod. And what I'm going to test is it going to use the same pod, because we've got another persistent volume available, but the basic feature of stateful set is it bounds to the same persistent volume it bound previously. Okay. Control D, kubectl delete pod nginx sts2. Okay, so that's getting terminated, and again the container is getting created and it's running now. Okay, now go back to the shell again on sts2, and if I do ls var dub dub dub, I can see that file, which means this container, this pod, mounted the same persistent volume. Cool, that's done. And what else I wanted to show you? Kubectl. Let's delete the stateful set. Okay, kubectl delete sts nginx sts. Okay, so that's getting deleted. Usually, when I read the documentation on kubernetes.io, they've mentioned that it's not 100% guaranteed that when you delete a stateful set, all the pods will get terminated. So sometimes you might be in a situation where you've deleted the stateful set, but the pods are still lying around. So the suggested method is to scale the stateful set down to 0. For example, kubectl scale stateful set, name of the stateful set minus minus replicas to 0. So you scale down the number of replicas to 0, which is going to terminate all the pods, and then you do the kubectl delete stateful set nginx sts. So that's the preferred way. Okay, the other thing you will be noticing is deleting the stateful set will not delete the persistent volume claims. Say you've still got all the persistent volume claims, you have to do that manually. Kubectl delete pvc minus minus all, and deleting that won't delete the pv. Kubectl get pv, so you've still got all the persistent volume. As I told earlier, we have deleted the persistent volume claim and the status has changed to released, but still it's not available for any other persistent volume claims, so you have to delete them as well. Delete pv minus minus all, that's done. Kubectl get pv. Okay, and finally what I wanted to show you was the pod management policy. If I uncomment this, and now I'm setting the pod management policy to parallel, and if I need to create the persistent volumes back. Okay, persistent volumes created, get pv, that's all there, status all available. Kubectl create minus f. Now let's deploy the stateful set. YAML service nginx headless already exists. That's okay. I forgot to delete the nginx headless service. Okay. I don't know if you have noticed. Let me delete all of them and start over again. Delete sts. Now I wanted to show you. Scale sts, the replicas down to 0. Okay, all the pods are getting deleted. Now delete the stateful set. Okay, so the stateful set is gone. So that's the suggested way. kubectl delete service nginx headless. kubectl delete pvc minus minus all. Delete pv minus minus all. Okay, so now we are back to where we were at the beginning. kubectl create minus f the persistent volumes. So all the persistent volumes got created. Cool. kubectl create minus f the stateful set. Okay, so you can see that all the containers are getting deployed at the same time, not one by one. And even if you apply a rolling update, the ordering is not going to be followed because of the change that we made to the pod management policy, which is parallel. Okay, cool. And let's do the cleanup. kubectl delete stateful set. kubectl delete service. kubectl delete pvc all. Delete pv minus minus all. Okay, everything is cleaned up. Cool. Stateful set. That's all I wanted to show you in this video. Just a quick recap. It has got three features. It's the way it differs from a deployment set is that all the pods will get a unique name, will get a unique network identity, will get a stable persistent volume. Even if you delete the pod, even if it gets rescheduled on a different node, it will still get the same node, same name, same network identity, same stable storage. And deleting a stateful set is not guaranteed to delete the pods. So it's better to scale down the replicas to 0 and then to delete the stateful set. And deleting the stateful set will not delete the persistent volume claim. You have to manually delete the persistent volume claim yourself. And again, as it's a static provisioning, deleting a persistent volume claim won't delete the persistent volumes. You have to delete it yourself. Cool. I think I've covered a lot in this video, and hope you enjoyed it. If you have got any problems, if you are stuck with anything, or if something is not working the way I explained in this video, please leave me a comment, and I should be able to respond to you in the comments. And if you like this video, please share it with your friends. And don't forget to subscribe to this video, because I've got lots of Kubernetes videos planned. At least I've got another 10 in my mind to do. And yeah, thank you so much for your patience for this lengthy video, and see you all in my next video. Bye bye.